In this video clip, we will discuss about CPU execution. We will see what is CPU instruction and how the CPU executes and compute those instructions. In order to make these video clips more understandable, easy to understand, we will use Brookshire Simple Machine. The Brookshire Simple Machine is a fictional CPU or prototype CPU that's mentioned in the book Computer Science Overview by Glenn Brookshire. The CPU is very simple. It contains only 16 general-purpose registers indicated by $0 to $F. And each register is only 8 bits. Inside the control unit of Brookshire Simple Machine, it has program counter, which is also 8 bits, and instruction register, which is 16 bits. The program counter is used for indicate the current location or the next location of the memory that it will fetch the next instruction. And the instruction register is a place that it keeps the current instruction that is being fetched inside the CPU, decode, and then perform the execution. In addition, Brookshire Simple Machine can connect to the outside main memory via bus. The maximum memory size is 256 bytes. So we'll use @ sign to indicate the address of the main memory from @00 to @FF. For example, in this picture, register 0 have the value A3. Register 1 has the value of 0A. If you take a look at the main memory, at address 00, we have the content value 11. This is in hexadecimal numbers. Or at address 05, the data is 12 or 18th in decimal number. To perform the execution, a CPU will do the machine cycle. This cycle, even though it's described for the Brookshire Simple Machine, actually is very generic and being used by most CPU, although they may have more steps. For Brookshire, they have 3 steps: fetch, decode, and execute. For the fetch step, in the step that the CPU retrieve the instruction from memory, the location of the next instruction that being retrieved in this step is indicated by the program counter or PC. Once the instruction is fetched from the memory, it's being stored in the instruction register or IR. And then the PC or program counter is incremented. In this case of the Brookshire Simple Machine, it will be incremented by 2 because the size of the instruction size is 16 bits or 2 bytes. That means once we retrieve an instruction, we will move to the next instruction, which is 2 bytes away. After the instruction is being fetched and stored in IR, the control unit will decode the bit pattern in the instruction register. This step called decode. The reason that it decodes the instruction because inside the instruction, which is 2 bytes in this case, it contains both instruction type or opcode, and also the operands, which indicate the register or memory that it needs to be performed the execution on. After the instruction is being decoded, the CPU will perform the execution step. In the execution step, the control unit will ask ALU or arithmetic and logical unit to perform the computation based on the instruction that is being decoded in the step 2. Once the instruction execution is done, we will repeat the cycle again by fetching the next instruction, decode the instruction, and then execute the instruction. This cycle is being repeated until we've met the special instruction called halt. The halt instruction is to stop the execution. Let's take a look in detail how the fetch step is being performed by the CPU. Suppose that the program counter is at 02. This means the next instruction will be being fetched from the memory at address 02 and 03. So once the CPU begin the fetch step, it will use the address containing in the program counter to fetch the memory to get the instruction. This fetch step, the control unit will bring in the memory content into the instruction register. And this is just the fetch step. Then they will perform the decode and then the execution.